In this question, they're asking us to calculate the indefinite integral of 3x squared plus 4 times e to the x cubed plus 4x minus 1 with respect to x. To do this, we're going to make use of the substitution method, and the first part of any substitution method question is to ask yourself, what should we be substituting for? What should we replace by u to make our lives easier? So in this question, we have a few options. The first option would be 3x squared plus 4. We could set that equal to u. We could let it be x cubed plus 4x minus 1. That could be u. We could let u be e to the x cubed plus 4x minus 1, or we could let u be the whole integrand. What we're going to choose in our example is u is equal to x cubed plus 4x minus 1. One reason we think that this might be a good idea is because if you take a look at this particular u and you take its derivative, you get 3x squared plus 4. And here is 3x squared plus 4. And so this, because this derivative or a multiple of the derivative of u is occurring in the question, this is usually a good indication that this is the u that we're looking for. So let's go ahead and try to use this u. So we take the integral of 3x squared plus 4 times e to the x cubed plus 4x minus 1 dx. And the first thing I'm going to do is just replace all of the x cubed plus 4x minus 1s by u. So we have this integral again, 3x squared plus 4 times e to the power u, because now the x cubed plus 4x minus 1 has been replaced by u, and we still have this dx here. Okay, so now we're in a position where we might want to try an integration, but the problem is that we have two different variables inside of our integrand. We have a u and we have an x, and we really don't like that. So what we're going to do is we're going to try to replace this dx by du and see what happens. So we kind of go off to the side here, and one way to get rid of this dx is to imagine that, well, we take the derivative with respect to x of u, and that gives us 3x squared plus 4x. Oops, 3x squared plus 4. And then we pretend as if this is a fraction. Of course, this is not a fraction, but it just so happens that if we pretend this is a fraction and solve for dx, it actually ends up working out nicely for us. So we're going to pretend this is a fraction and solve for dx, so we're going to multiply both sides by dx. So I get du is equal to 3x squared plus 4 dx. And now I'm just going to divide both sides by 3x squared plus 4 so that I get the dx by itself. So at the end of the day, I have dx is equal to 1 over 3x squared plus 4 times du. So now wherever I see a dx, I can replace it by this. So that's what I'm going to do. So this integral equals the integral of 3x squared plus 4 e to the power u. And now with my new version of dx, I can put it in here. So dx is now 1 over 3x squared plus 4 times du. And this is a very nice situation, because this 3x squared plus 4 on the bottom can cancel out with this 3x squared plus 4 on the top, which is why this kind of idea of having the derivative of u kind of already in the question, this is why we want it to be like that, so we can cancel these things out. And at the end of the day, we're left with, once everything cancels out, e to the u du. So now, because we have only one variable, namely u, in our integrand, and we're integrating with respect to that variable, we can actually proceed and do this anti-differentiation. So the antiderivative of e to the u du is just e to the u plus a constant c. And now what we want to do is we want to kind of replace all of the u's with what they're actually equal to, because we want to go back into writing the answer in terms of x. So let's replace the u by what it actually is. E to the x cubed plus 4x minus 1 plus constant c, and this is our final answer.